Hi, this is Sudeep, and I welcome you back to this wonderful journey of learning structure analysis with STAAD.Pro. I have been associated with Bentley and with STAAD.Pro for 17 years now, working in multiple roles in STAAD.Pro technical team, but have been primarily helping engineers around the world to solve the structural engineering problems with STAAD.Pro. Today, we are in the final session related to the material and property modeling in STAAD.Pro, and today we'll discuss exclusively on material modeling. But before we go forward, please take a moment to subscribe to this channel and join us in this wonderful journey of learning structural engineering with STAAD.Pro. Till now, we had been doing material modeling along with sectional property modeling without paying much attention to it. For example, when we had been assigning concrete sections, we had been selecting the material concrete along with it. For example, when we were to define a rectangular section of 0.4 by 0.25 meter size, we had selected the material concrete along with it. If we had intended to change the material, we could have clicked on this drop-down switch and could have selected from the list of standard materials that is available within STAAD.Pro. And when we had added this section to the properties whole structure box, you'd see that along with the section, the material concrete had also been added with it. Or if we had selected a section from the standard steel section database, in that case, we had selected the material steel along with it. And again, we could have changed the material by clicking on this drop-down switch. And when we had added this section to the properties whole structure box, we had also added the material steel along with it. These materials that we had selected are already a part of the standard material list within STAAD.Pro. So now if we click on the Materials tab, which comes sequentially after the Properties tab, on the right side of the screen, we see the Material Whole Structure box. In the Material Whole Structure box, we see two tabs, Isotropic and Orthotropic. Now, what do we mean by isotropic material? Well, it means that the materials have similar properties in all the direction. Now let us see what specific properties are defined as a part of the material. So let us double click on any of the materials available. So let us say that we double click on the steel. A box pops out listing all the material properties of steel. We see that the Young's modulus has been defined, the Poisson's ratio has been defined, the density has been defined, the thermal coefficient, critical damping, and shear modulus has been defined. Now, all these are the material properties. Now, we do not need to understand what all of these material properties mean at this point of time, and it is sufficient if we understand the modulus of elasticity at this point of time. So, what is modulus of elasticity? Well, when a member responds within the elastic limits of its constituent material, the stress of the material is proportional to its strain. In other words, if we plot the stress versus strain, we get a straight line, and the slope of the line would be representative of the elastic modulus of the material. However, you will see a lot of variations of the steel material itself, like we have in the list steel 36 ksi, steel 50 ksi, and again steel 275 Newton per millimeter square and steel 355 Newton per millimeter square. So what do they all mean? Now this means various grades of steel. Steel comes in different grades, which causes differences in material properties. However, we will only consider the standard steel and concrete materials in this series. However, there can be questions in structural mechanics, especially related to the displacement calculations and while analyzing indeterminate structures, where the question will ask us to consider a given value of E. In such cases, we would need to create a new material to define the specified modulus of elasticity for the material. Let us consider the goalpost frame model. Now let us say that for this particular member, we want to assign ISMB 100 section of steel material. So we go to the section database. We know that the ISMB 100 section is a part of the Indian section database. So we go and click on the Indian database, go to the S shape, select ISMB 100, ensure that the material is steel, and add it to the properties whole structure box. Now, as you know by now that we have added both the section and the material in the properties whole structure box, which we can assign it to this particular member. Now, for the top member, this one, we want to assign a concrete material with a section size of 0.25 meters by 0.4 meters. So we go to the define button, we click on the rectangular option, define the section as 0.4 for depth and 0.25 for width. Ensure that the material is concrete and add it to the properties whole structure box. Again, we have the section and the material added. So we want to assign this section to the top member. Now for the remaining member, which is this one, we want to assign a ISMB 125 section, but we want to assign a user-defined material here which has a modulus of elasticity of 250 into 10 to the power 6 kilonewton per meter square. So what do we do? So we go to the section database again and go to the Indian database, select ISMB 125, but we do not want to assign the steel material this time. We want to define user-defined material. So we uncheck this box and add the section to the properties whole structure box. Now what you will see is that we see that the section is being added, but no material has now been added. So what we do is we assign this section to the last member of the model. So, but we remember that in this case, we have not assigned the material. Now, for the material of this particular member, we would need to define the material in the first place. So we go to the materials button and we have to define this material. We say that the name of that material is mat1. As soon as you type the title, a new title, you would see that this the material properties becomes editable. So we have to define a 250 into 10 to the power 6, which we can write in this way. And we retain the other material properties as it is. Now, this is how we have defined a new material. So we say OK, and it says that such a material exists. So let us name it as material 2 instead and say OK to it. And we can see that a material 2 has been added to the list of the material whole structure. Now, what we can do is we can take the use cursor to assign method and click on the assign button and assign this material to this particular column. So we have now assigned a user-defined material to this last member of the goalpost from frame model. So now if we go back to the properties whole structure box, we can now see that with ISMB 125 for the third case, we have material defined as mat2. So now that we have defined a user-defined material for the third member, we can go into the text editor. We are prompted to save the file, so we save it, go into the text editor, and we can see closely that we have defined 3 materials. See, defined material start, is where the material definition starts, and end defined material. So between these two lines, between this line defined material start and end defined material, we have all the members defined. The first member defined was isotropic steel with all its standard material properties. The next material that has been defined is isotropic concrete with all associated member properties. We had defined a Mat 1 also, which was done before I started working on this model. So I had created another material, Mat 2, with all the associated material properties. Now, once that has been done, we scroll down, and if we go to the constant commands, we can see that we had material steel assigned to member number 1, material concrete assigned to member number 2, and material mat 2 to member number 3. Now remember again that steel and concrete came from the standard list of materials, while mat 2 was the user defined material. So now I hope this helps you to understand how we can define the standard materials and the user defined materials to members in the STAAD.Pro model. So with this, we complete the whole section of modeling materials and properties. We get into a new section after this about assigning supports. However, in the next session, we will briefly touch on the subject of beta angles. I hope you have enjoyed the session today. If you have, please do like this video and help me to reach out to more students who might be looking for a similar content. See you in the next session. Till then, bye bye.